this is Dr. Hobble. I'm going to help you with this problem. It says select all the expressions that represent the area of the shaded rectangle on the left side of figure B below. So we just want to find the area of that blue rectangle. And what I want you to be careful about is, here I'm going to be later selecting some items from this checklist. Yours are going to appear in a different order on Desmos most likely. So you'll need to read them carefully to make sure you're making the proper selections. Okay, so first let's remind ourselves, how do we find the area of a rectangle? So our formula for the area of a rectangle that's area is base times height, or you might see it as length times width. And what is going to be, you think, the strategy for finding the area of this blue rectangle? Because we know that overall it has, maybe we could say the base of the larger rectangle is 7, and the height would be 4. What's this number going to be? If all the way across it's 7 and then the white part is 2, how would we find that? Well, we would do 7 minus 2, and this is 5. So some different ways we could think about how to find the area of this triangle. Let's go ahead and let's let 4 be our height. And this will be our base. So one kind of quick way we could find the area is just using those substitutions that we found. So we said that the height is definitely 4 and the base was 5. So we could just say 5 times 4. And honestly, these might be easier to compare to our list if we go ahead and let's actually switch the base and height. So I'm going to say that the height is 5. I'm going to say the base is 4. Because again, it doesn't matter. The order doesn't matter. You might see why I decided to do this. So first, if we take 4 as the base and 5 as the height, we get that the area is 4 times 5. See how that's in my list? 5 times 4, it's equivalent to it, but this way we have fewer steps later. Well, what's another way that we can think about the area? Well, we could say the area is 4 times. How did we find that height originally? How did we know that this was 5? What calculation did we do? We did 7 minus 2. So the area could also be found by taking 4 times the quantity 7 minus 2. And finally, for our last way, let's think about finding the area of the whole triangle and then subtracting the area of the white triangle. So the blue triangle, that area is 4 times 5. What's the area of the white triangle? 4 times 2 square units. So the area of the entire rectangle is 4 times 7. And then we can subtract the area of that white rectangle. And that's going to be 4 times 2. So these would be all the different ways, not all of the different ways, there are probably even more ways, but these are the 3 ways that we'll definitely see in our list. So 4 times 7 times 2, that's going to be too much. That would actually probably represent like the volume of a box or something. 4 times 7 minus 4 times 2, that's in our list. 4 times the quantity 7 minus 2, that's in our list, and we even saw why. 4 times 7 plus 2, that's going to be too much. That one's not in our list. 4 times 7 plus 4 times 2, That's too much, because that would be like the area of the whole rectangle plus even more. 4 times 2 minus 4.7, that's backwards from what we want. That would actually end up being a negative number. And then 4 times 5, that one's in our list. And you'll notice that all the expressions that we selected, if you evaluate them, they'll evaluate to 20. So that's another way that we can feel confident in our answers. Okay, so thanks for working this problem with me, and hopefully you feel confident tackling some of these yourself.